Today I'll talk about naming of alkenes. So alkenes are hydrocarbons which have a double bond, and there are two types of alkenes. We have internal alkenes and terminal alkenes. So let me show you this model which I made. This is the carbon-bromine bond. This is a bromine atom, and this is the carbon-carbon double bond. This green, it's carbon-carbon double bond, and the double bond is at the end of the chain, and so it is considered to be a terminal alkene. So this is a terminal alkene because the double bond is at the end of the chain. In terminal alkenes, one of the carbon atoms that carries the double bond will have two hydrogen atoms attached to it, like this. So this is an example of a terminal. This is an example of a terminal alkene. So for internal alkenes, an example of an internal alkene would be this. This is an internal example of an internal alkene. So in an internal alkene, this is the carbon-carbon double bond. This is the green double bond right here, and this bond is within the parent chain, so it's considered to be an internal alkene. And I'll talk about the geometric isomers of this. This particular case, it is the hydrogen. This is the two hydrogens. They are on the same side of the double bond, and so this is considered to be cis. In order to better understand the geometric isomers of alkenes, please visit and review my video on classification of isomers, where I've explained the cis, trans, E and Z alkenes and how to name them. So this, when the two hydrogens are here, right here on the opposite side, they are this, and this molecule will be a trans alkene. So this is a di-substituted alkene because we have two substituents on it. This is the methyl substituent, and this is another substituent, this whole substituent right here. So it's a di-substituted. And if you can replace this with another substituent, then this is considered to be tri-substituted because you have one substituent here, another one here, and this whole thing is another substituent. So it's tri-substituted alkene. For tetra-substituted alkene, even this hydrogen would be replaced by an alkyl group, and then it would be tetra-substituted. Let's look at another example. This is a cyclopentane ring, five-membered ring, and you have a double bond right here. This is the double bond. This is the two carbon atoms bearing the double bond. This is also this bond is outside the ring, and I'll talk about this, what it's called once it's outside the ring. It's useful to draw to make models to better understand the stereochemistry of alkenes, and I have made models using the organic chemistry basic set from Maruzen. So this is the company I got it from. So you can use any other models, whichever works and whichever is available, but I found these to be useful. So in order to name alkenes, you just replace the A in alkene with E. A couple of things you need to remember is ranking of functional group. This is important in order to find out which what the parent name should be. So if you have alkene and alkyne and halide functional groups in a molecule, then alkene will have a preference over alkyne or halide. So let's see how to name functional groups as substituents of parent chain. So the functional group can be a halide, and you'll name it as fluoro, chloro, bromo, or iodine, depending upon if it's fluorine, it will be fluoro. If it's chlorine atom, it will be chloro, and so on and so forth. Alkanes, which are its side chain, will be named as alkyl. So in this case, example will be ethyl. And ethyl comes from ethane, where the ane is replaced by YL. In case of cycloalkanes, as a substituent, you'll call it cycloalkyl, like cyclopropyl, cyclobutyl, cyclopentyl, and so on and so forth. If there is a double bond, which is a substituent, then you'll name it as alkenyl. And if a triple bond is a substituent, you'll name it as alkynyl. Example is ethynyl. So this is how loss of hydrogen in alkane, alkene, or alkyne will result in the substituent. So name of substituent when one carbon of the double bond is part of the ring. So this is the example I was talking about. So in case where only one of the carbon atoms of the double bond bearing the double bond is a part of a ring or a chain, then that double bond is considered to be a substituent, and it's called methylidene. So let's look at this example. So this is a cyclopentane. This is a cyclopentane ring. Let me put this hydrogen here that was missing. So this is a cyclopentane ring. This is a carbon-bromine bond. This is the carbon-carbon double bond. One of the carbon atoms is within the ring, and the other carbon atom bearing the double bond is outside the ring. So this is called the methylidene double bond, right here, carbon-carbon double bond. So in case of for ethylidene, ethylidene is this will be ethylidene. Okay, so this is ethylidene. So you can see that this is the ethyl group that's attached to the double bond right here. So that's called an ethylidene group. So that's how you name it. And if there's a propyl group, then you call it propylidene, and so on and so forth. So it's pretty useful to draw to make models and look at the stereochemistry. So let's learn how to name alkyl groups. I have covered this extensively in my previous video for functional groups and also alkanes, naming of alkanes. So you may want to look at those videos, but I'll briefly go over this very quickly. So these all are branched substituents. So this is the neopentyl. Neopentyl is the common name, and it's also written as in this form, or you'll see in molecules like this. So this is the neopentyl. This all is neopentyl. Neopentyl is the common name, and the IUPAC name is 2,2-dimethylpropyl. So the carbon atom of an alkyl substituent that is attached to this is the parent chain. The carbon atom, this is the carbon atom that is attached to the parent chain, is numbered as 1. So this is 1 and this is 2. So at carbon atom 2, you have 2 methyl groups attached to it, and hence it's called 2,2-dimethylpropyl. Propyl because there's 1, 2, 3. So this is a chain, a substituent chain. Okay. So make yourself familiar with all the different alkyl groups, how they look when it's written in a stick format, or it's written in the bond line format. So make yourself familiar with these structures. You'll keep looking at these structures throughout your organic chemistry class. So IUPAC rules for naming alkenes. So there are several steps you need to follow. The first step is locate the longest carbon chain, and this is considered to be the parent chain. But if there is a ring, then the ring will have a preference over the parent chain. If both the carbon atoms are of the double bond are in the ring, then it's called a cycloalkene. But if only but if it's a chain, then it's called an alkene. And we spoke about this when one of the carbon atoms of the double bond is in the parent is in the parent chain and the other one is not, then it's named as alkylidene. So all groups like halide, alkyl, alkenyl, and alkenyl attached to the parent chain are considered substituents. So always start numbering the carbon atoms of the alkene from the end that is closest to the double bond. For cycloalkenes, the double bonds will be numbered 1 and 2. If there is a symmetric alkene, then the first substituent was given the lowest number. So there are additional rules for naming alkenes. So this rule is for identifying the stereochemistry as mentioned before. So if cis means the same side and trans means opposite, and that's used for di-substituted alkenes. The Z means same side and E is opposite side, and it's used for tri and tetra substituted alkenes as mentioned previously. You can also review my video on the functional groups and naming of organic molecules and also refer to the video about classification of isomers where I've explained the geometric isomers. So all these cis, trans, E and Z are the geometric isomers. So we can use prefixes like di, tri if the molecule has several of the same substituent. However, remember that this prefix is not considered during the naming of the molecule in order of alphabetical. If there is a branch substituent, as I mentioned earlier, the carbon atom attached to the parent chain or the longest chain is numbered 1. Prefixes for substituents are considered during naming the molecule. And if there's several double bonds, you can use the prefixes di, tri, and so on and so forth. And so in order to name the full molecule, always start with the stereochemistry, followed by the location of the double bonds, and list all the substituents alphabetically, preceded with the numbers to indicate their location, and then the name of the parent ring or the chain as applicable. So let's look at some example. So this one, you have the double bond right there in the molecule. So this is considered to be the parent, and this entire is considered to be the substituent. And on this on the pentyl side chain, we have the ethenyl group on carbon atom 2. So this is named as 2-ethynyl pentyl cyclohexane. So the substituent is you have to put it in parentheses. Let's look at another example. In this particular example, this is a tetra substituted alkene because there are no hydrogens attached to the double bond, so it's tetra substituted. In order to find whether it is cis or trans, you need to look at the substituents attached to each carbon. So let's consider the substituents attached to carbon atom 3. So you have bromine and you have ethyl. So bromine has a higher atomic number, so it has a higher, this is considered as the higher priority group between these two. And then let's consider the substituents on carbon atom 2. So methyl and methoxy are the substituents. So these are the two substituents on carbon 2 of the double bond, and oxygen is a higher atomic number, so it has a priority over methyl. So when the two priority groups, in this case labeled as red, are on opposite side, then and it's a tetra-substituted alkene, then the alkene is labeled as E. So the substituents are bromo and methoxy, and so it's called E, 3-bromo, 2-methoxy, 2-pentene. So this is the longest carbon chain, and you start numbering from the end that is closest to the double bond. You cannot number it from this side, because then you'll have 1, 2, and 3. So it's number 3 is more than number 2. So you always have to have the lowest number for the double bond. So this is considered as an internal alkene because it is within the parent chain. So let's consider another example. In this particular case, you can see this is a terminal alkene, and this carbon atom, which carries the double bond at the end, has 2 hydrogens attached to it. So this is a characteristic of a terminal alkene, and this is internal alkene. In this particular case, this is a di-substituted alkene because these are the 2 substituents attached to this double bond. And when the 2 hydrogens right here, since they are on the same side, it's called cis. The other substituent here, right here, is we have the ethyl substituent and the ethynyl substituent. So there are 2 substituents on the parent chain. So the parent chain is a 9 carbon atom. It's a nonane is the parent chain, and there are 2 double bonds. One is an internal double bond and the other is a terminal double bond. So let's see how to name this. So again, we'll be naming it in alphabetical order, all the substituents, and we will also make sure that we name the stereochemistry of the double bond and indicate the locations. So this is cis double bond, so it starts with cis, and then you have the locations of the substituents, 5-ethyl, and followed by 6-ethynyl. This is alphabetical order, and then 1,3 non-diene. So 1,3 is the location of the 2 double bonds, carbon 1 and carbon 3, and nana is because there are 9 carbons in the parent chain, and diene because there are 2 double bonds. Di indicates 2 double bonds, and then ene is for the double bond nomenclature. Let's look at another example. In this particular example, the double bond is inside the ring, and we have 2 substituents, methyl and methoxy. The numbering for a double bond within the ring, you have to have the double bond should be numbered carbon 1 and carbon 2, and then this is 3, this is 4, and this is 5. So the way you number, write the name is 3-methoxy 3-methyl cyclopentene. So again, in alphabetical order, METH. So it's 3-methyl 3-methyl 3-methoxy cyclopentene. So the correct name is, so after METH, you have O is first, and then comes Y, so it's called 3-methoxy 3-methyl cyclopentene. So that's the correct name, and it's an internal alkene because the double bond is inside the ring. Let's look at another example. In this case, you have double bond and a triple bond in the parent chain. The parent chain is 1, 2, 3, 4, 5, 6, 7. So it has 7 carbon atoms in the parent chain, and the numbering, if you recall that If you have a double bond and a triple bond, then the double bond has a preference over a triple bond, and so you have to start numbering it from the carbon atom that's closest to the double bond. So you have numbered it from this side and not from the other side. And the substituent is fluoro right here, and the two hydrogens are on opposite sides, so it is a trans double bond from a trans double bond, and so it will be named as trans 2-fluoro 3-heptene 6-ine. So 3 is the number for the double bond and 6 is the number for the triple bond. Thanks for watching. Like and subscribe. I have additional examples, it looks like. So this is additional example. Let's consider this particular molecule. In this, the double bond is within the ring, and you number the atoms as 1 and 2, and then it will be 3. So the substituent is always given the lowest number. You do not start numbering it from the set and say 1, 2, 3, 4, 5, 6. So if you do it this way, that's the wrong numbering, because you'll give the substituent a higher number. Also, the carbon atom that is attached to the parent ring is numbered 1 right here, and so the substituent iodo on the substituent ethyl is that's a substituent. And let's see how to. So this is called 1-iodoethyl substituent, and it's located on carbon atom 3 of the parent ring. So this is the parent ring. It's called the cyclohexene ring, and it's located on carbon. So you put a number for the location of the substituent right in front of it. Let's look at another example. Here you have one of the carbon atoms bearing the double bond outside the parent chain. So the parent chain is 1, 2, 3, 4, 5. You could have 1, 2, 3, 4, 5, but 5 is not the longest carbon chain, so this is the correct longest carbon chain. And then if you recall that you have to basically number it in such a way that you give the substituents the lowest number. So that's the reason you start numbering it from this side and not from the other side. So the substituents, this is the methylidine substituent right here. That's the CH2 bearing the double bond. Then you have the bromo substituent, and then you have the two methyl groups as substituents. And so it's called 2-bromo 3,3-dimethyl 4-methylidine hexane. So the parent chain is 6-carbon hexane, and 4 indicates the location of the methylidine, and 3,3 is the locations of the two methyl groups, and bromo is a carbon atom 2. Let's look at another example. In this case, this is cyclobutene ring, because it has 1, 2, 3, 4, and the double bond is within the ring. On carbon atoms 3 and 4, you have two methyl groups. If you recall the convention, this is the wedge, and the wedge indicates that this methyl group is on the top of the ring, whereas this hash represents the methyl group is below the ring. So there are two methyl groups as substituents, and it's called, since one is below and one is above the ring, it's called trans 3,4-dimethyl cyclobutene. Let's look at another example right here. In this particular case, you can see that there are three. This is a double bond, and there are three substituents. Substituent is one is methyl, here is ethyl, and then this is a big substituent right here. So it has three substituents attached to the double bond, and it's a tri-substituted alkene. And in order to find whether it is E or Z, you look at the substituent on carbon atom 3. So we have methyl and ethyl, and ethyl is a higher priority group. If you look, methyl, carbon and 3 hydrogens are attached here, whereas here carbon, 2 hydrogens, and then it's further attached to a methyl group. That's the reason ethyl is a higher priority. And then you have between hydrogen and the substituent, and clearly the substituent is the priority, our largest substituent. And so the two substituents, which are in red color right here, are the high priority groups on each of the carbon atoms pairing the double bonds, and they are on the same side. So this particular substituted alkene is labeled as Z. Z means same side. So it's called Z6-chloro-3-methyl-3-octene. 3-octene is because you start numbering it from the side which is closest to the double bond. So you start numbering it from this side, and so it's on carbon atom 3. You have the double bond. You have a methyl group on carbon 3, and also a chloro substituent on carbon 6. Thanks for watching. Like and subscribe.